Hello everyone. Today we are at the chemistry lab and we are going to start the chemistry practicals today. So generally the chemistry practical is broadly divided into two, that is qualitative analysis and quantitative analysis. So this year we will be dealing both qualitative as well as quantitative. In qualitative analysis we have got salt analysis and organic functional group analysis, which we will see later. And now today in this class we are going to mainly deal with quantitative analysis. So before going into what it is, let me explain about what is quantitative analysis. So in quantitative analysis we take a substance which we make into a solution. Suppose if you are having some substance and if you take a small amount of the substance and dissolve it in water and you get the solution, and if you are asked to find out the amount of the substance present in it, we call it as quantitative analysis. And if you go for qualitative analysis, you can see the substance, and by doing experiments and all, if you find what the substance is, it comes under qualitative analysis. So qualitative just to identify what the substance is, and quantitative to find the amount of substance present in it. So for this we have got a method called as volumetric analysis. So today in this class we are going to deal with volumetric analysis. So in volumetric analysis we can analyze or estimate the amount of a base as well as acid. So in volumetric analysis we are going to estimate the mass of a base. In this class we are going to deal with the estimation of a base. So if you want to find out the amount of a base, we should have a acid with it. That is, we go for a neutralization reaction. As we all know, what is neutralization reaction? It's a reaction of a acid with a base to give salt and water. For this practical, we have got different steps. For example, the first step is the aim of the experiment. Then comes the principle behind it. After that, we have got materials required. After the materials required, we go for the procedure. And after that, we have got observation and calculation, and finally the result. So each practical undergoes through these steps. That is the first one with aim, then with principle, then materials required, procedure, observation and calculation, and finally the result. This is the steps involved in a chemistry practical for volumetric analysis. So there are many new terms which will not be familiar to you. So as we do the experiment, you can see what it is and what are the definitions for it. So let's do the practical and see. So today's experiment is estimation of sodium hydroxide. So for this experiment, the aim is to estimate the mass of sodium hydroxide in the whole of the given solution. For this, you have been provided with
3.7 gram per liter of HCl.
So the experiment in volumetric analysis, we call it as titration. This titration word will be a new word for you, but this is an important term, titration, just keep that in mind. Now first of all, let us get familiarized with the apparatus used for volumetric analysis. So the materials or the apparatus required are, the first one which you could see this is a conical flask, which I think all of you will be familiar with it. So this is a conical flask just to take the chemicals in it. The experiment is generally conducted in this conical flask. Now we will go for funnel, which everybody will be familiar. So this funnel is being used here in this volumetric analysis, and we have got glass rod for stirring purpose and for transferring. Now another familiar apparatus, that is beaker. Now we will move on to an important apparatus involved in volumetric analysis or the titration. This is called as a Buret. You could see a long tube with a knob at the bottom. So this is the main apparatus used for volumetric purpose, that is for doing titration. So this is of 50 ml capacity. You could see small graduations. The measuring or you can find out the measurement by using this scale on the Buret. 50 ml at the bottom and 0 at the top. So, when the liquid falls down, you could find the measurement using this scale. So, the flow of the liquid can be controlled using this knob at the bottom. So, the purpose of this particular apparatus is that you can control the flow by, you can make a drop, a single drop, you can use, that is drop wise you can take the solution. So, generally when you conduct this experiment with acid and base, acid is taken in the burette. So, this is the burette and it is generally mounted on a burette stand. Okay. Then we have got another important apparatus, which is a new apparatus for you. This is called as a pipette. Generally this is used for transferring substance, that is transferring solutions. This is of 20 ml capacity, and in this tube, that is that pipette, you could see a small line over here. So, when you take any substance till this line, it is said that this liquid will be 20 ml. So, if you want to transfer exactly the 20 ml, you have to use this pipette. So, volumetry generally deals with volume of substance. So, the volume must be exact. For this we use pipette. So, the burette and the pipette main apparatus involved in titration. Then this is called as standard measuring flask. In short we call it as SMF. So, if you want to make up a solution, that is a solution of known, to make it of a known volume, that is 100 ml. If you want to convert a substance to 100 ml, we use this standard measuring flask. In this apparatus also you could see a mark over here. So, if you fill the SMF till this mark, it is said that this liquid will be of 100 ml. So, if you want to make up a solution to 100 ml, you have to use this SMF. So, this is a small reagent bottle and the solution to be analyzed is given in this reagent bottle. So, this is the sodium hydroxide solution given to us to estimate it. That is, we are going to find out what is the amount of sodium hydroxide present in this solution. Now, the mass is unknown to us as well as the volume. We do not know what is the volume of the solution. So, first our step is to convert it to a known volume. That is, as I said earlier, we have got apparatus SMF. That means, if you fill the solution till here, it is of 100 ml. So, we are going to transfer this solution to this SMF and we are going to make it to 100 ml. So, this process we call it as making up the solution, which is an important step involved in this. So, let us do the experiment and see. So, before doing the experiment, it is compulsory that you should wash or clean the apparatus very well. So, wash it with water. Today we have kept everything ready. Now, my first step is to transfer this solution to a SMF, standard measuring flask, so that I can make it to 100 ml. So, let us see the steps involved in how to transfer. So, watch carefully while transferring. So, let us transfer this quantitatively to the SMF. So, these steps we have to do it very carefully. So, as the liquid has to be transferred without spilling, we have to use a funnel for this. So, whenever you are mounting a funnel on this SMF, we should keep a paper in such a way that just to give a small air gap to it. Okay. So, the funnel is ready with the SMF. Now, we are going to transfer it. So, as the liquid has to be completely transferred without even spilling a single drop, first of all, wash the lid with some amount of water, so that there should not be anything on any liquid on the lid. So, just wash it and keep it away. Now, it is the complete transfer of the liquid. That is, for this to avoid spill, we use a glass rod. So, carefully pour through the glass rod. Pour or transfer the solution using a glass rod. So, there should not be any spilling even of a single drop. Now, the glass rod should not be taken out, it has to be placed there itself. Now, there may be some amount of substance inside the bottle itself. So, let us take some water, small amount of water, just roll it. Now, again transfer. Keep the glass rod there itself. So, this process has to be repeated thrice. Now, it is the turn of the glass rod. Now, we have to wash the glass rod. Just keep away the glass rod. Now, it is the turn of the funnel. Just rotate the funnel like this, so that every drop on the funnel gets into the SMF. Okay. Now, at the end you have to wash the end of the funnel. The experiment is done. So, now we have completely transferred the solution from the reagent bottle to the SMF. Now, as I said earlier, there is a small mark on the top. So, we have to fill it till here by adding water. See that the mark should not be exceeded. The level of the solution should not go above the mark. So, for this we use water. Let us add water to this to make it till the mark. So, while adding water we have to be very careful. So, once it reaches just below the line, you have to add the water drop wise. This can be done with the help of the wash bottle itself. Okay. So, we have filled up to the mark. So, whenever you are having a colorless solution like this, when you are taking the mark, the reading or the mark, see that the lower meniscus touches the line. So, when you see the water surface, it has got an upper meniscus and a lower meniscus. So, whenever you are taking any volumetric analysis, when you are using a colorless solution, you have to take the lower meniscus. So, that is the curved part. The bottom part should touch the mark. Now, we have transferred and we have made up to 100 ml. Now, we have to uniformly shake, we have to shake the solution to make it into a uniform concentration. So, for this purpose, we have to close the lid of the SMF and we have to shake it properly, shake it thoroughly. So, for this we use this method, just tilt the SMF, shake it well, do it again. You can do this at least thrice so that you get a uniform concentration. Now, the 100 ml sodium hydroxide is ready. So, for the experiment we need 20 ml of the base. To transfer 20 ml, we take help of the pipette. So, whenever you are taking a pipette to transfer any substance, you have to rinse the pipette with the given solution. Rinsing means, that means it may contain some small amount of water. So, to avoid that, we take help of the rinsing process. Rinsing, just I will show you how to rinse it. So, how to use the pipette? The pipette, the solution rises with the help of our mouth. That is, just dip the pipette inside the SMF, suck it with the help of your mouth. For closing the mouth, or stopping the solution, you have to use this finger. Just close the end of this pipette to just stop the flow or the. Okay. So, I have taken small amount of the substance and to spread it throughout to avoid any single drop of water in it, just roll it. Spread the solution throughout the pipette. It contains only sodium hydroxide. So, once you stop here with the finger, it closes. Now, I have taken a little bit more than the line. Even for pipette, as I said, it has got a mark. So, you have to see that the lower, that is the lower meniscus should touch the mark. Now, once it reaches the mark, the lower meniscus touches the mark, means hold it tightly. Now, take a clean conical flask and transfer it. Just leave the finger, the solution drains. You could see small amount there, just give 2 taps at the bottom. Now, the conical flask contains 20 ml of the base. Now, we have to fill the burette with the acid. So, as I said, whenever we are filling anything, we have to rinse it well. So, the given acid is ready here. Now, take small amount of acid in it. To avoid all the water particles inside the tube, just place it horizontally and roll it. Spread the solution everywhere. Once it spreads throughout the tube, drain it off. Now, close the knob, fill the acid till the top mark. Always take a little bit above the mark, and by doing this, by regulating the knob, you can adjust the level. Okay. Here also the lower meniscus should touch the mark. So, once the burette is filled, mount it on the stand. Now, acid is ready, the base is ready. Now, to understand, now this is a neutralization reaction, acid reacts with the base, but to know whether the reaction is ended or not, we use an indicator. So, here indicators indicate the end point, that is the completion, just the completion of a reaction. So, in this experiment, we are going to use phenolphthalein as the indicator. Phenolphthalein is pink in base and colorless in acid. So, once we do the experiment, you can see that at the end point, the pink color disappears, it becomes colorless. So, that point is called as the end point. So, phenolphthalein indicator, we are going to add 1 drop of it. Okay. Now, the color has become pink in the base. Now, we are going to start the titration. We are going to react the acid with the base. This process is called as titration. Just keep it below, adjust the burette. So, when you are handling the burette, see that you keep your left hand for controlling the knob, and this has to be constantly stirred. So, always remember the left hand for controlling the knob and right hand for stirring. So, let us start the reaction or do the experiment. So, you can get the either dropwise or you can get a free flow from this. When the acid is being drained, you can see the level decreases. So, we are analyzing it drop wise. We are almost nearing to the end point. You can see the color has become mild. So, we are very close to the end point. So, when we are close to the end point, see that you do it drop by drop. Okay. Now, it has become colorless. So, now we have reached the end point of it. The pink color has become colorless. Now, to take the reading, take out the Buret in your hand. You could see the level. So, whenever you are measuring or seeing the scale, see that you keep this level just parallel to the ice. Now, it is coming about 17.1. So, you have to count from the top, that is from 0 it has come to 17.1. So, this scale is of 0.1 graduation. So, it gives about 0.1 difference. So, this value is 17.1 ml. This is how we do the titration. Now, we have to get a concordant value, that is the same experiment has to be repeated so that you get the same value. Now, we have got 17.1. So, if you repeat the experiment, you should get a 17.1. Otherwise, you have to go for once more it has to be repeated to get a concordant value. A concordant value means value which is same with the adjacent experiment. If the adjacent experiments are having the same value, we call it as concordant value. So, for titration we use concordant value. So, from this experiment we understand that 17.1 ml of HCl is consumed to neutralize 20 ml of NaOH. So, with the help of this volume, we are going to do the calculation and we are going to find out the mass of the sodium hydroxide. So, since we are using this volume, we call it as volumetric analysis. So, let us move on to the tabulation and calculation.